Hello. So here you will see two special right triangles that should be jogging your memory from geometry. Today we will be connecting these right triangles to the unit circle. Let's do a quick little recap, even though these were already covered in geometry, okay? This video is going to be focusing on the 45, 45, 90 triangle. Where does he come from? Well, we have a square with side lengths x and 90-degree angles. If I were to draw a diagonal, I would bisect these angles over here, making them 45 degrees. And I could kind of pop this triangle out, this one, and take a closer look at him over here. All right. This angle is still 90. This side length is still x. This side length is still x. This angle is 45 degrees, and this angle is 45 degrees. All right, we've got lots of information about him. What if we wanted to find the length of the hypotenuse, also known as c, right? We could use the Pythagorean theorem. I would have x squared plus x squared equals c squared. This gives me 2x squared equals c squared, square root both sides, and I would get rad 2 times x equals c. So I'm going to go ahead and put that on my figure because now I know what c is. And this is super awesome because now I know that the ratio of my sides in a 45, 45, 90-degree triangle would be x to x square root of 2. So for example, if x equaled 3, I would know that this also equaled 3, and that this side length over here would be 3 rad 2. That's pretty awesome. I figured that all out without having to do a single calculation. Useful, useful, useful. Okay. I'm erasing. All right. What if I told you that c equaled 1, right? What if I told you now that c equals 1? Well, I could certainly solve for x. It wouldn't be hard. I know that if this equals c, this equals c, I could just set x square root of 2 equal to 1. And I could solve for x. Divide by square root of 2, divide by the square root of 2. I would get x equals 1 over the square root of 2. And remember, we like to rationalize when there's a square root in the denominator. So I would get rad 2 over 2. X equals rad 2 over 2. So when c equals 1, x equals rad 2 over 2. X equals rad 2 over 2. All right, cool. Hold that thought. Remember, in the unit circle, bear with me. Let me just draw a nice little circle here. That's not a straight line. Okay. This is like a really horrifying looking axis. I apologize. Just go with it. In the unit circle, who looks so bad? In the unit circle, remember I told you that there is a radius of 1. This 45, 45, 90 triangle translates to the unit circle simply because of this idea that the radius is 1. So if I say, hey, I have a 45-degree angle here with a radius of 1, I know the side lengths of this triangle inscribed in the unit circle here would be rad 2 over 2 and rad 2 over 2 because this is the hypotenuse, this is the reference angle of 45 degrees, and super awesome. I'm just using the information that we figured out above. This is great for a few reasons. This is great because now we know that the sine of 45 is rad 2 over 2 because the sine of 45 degrees is opposite over hypotenuse. Oops, that is a highlighter. Goodbye. Same idea here. We know that the cosine of 45 is rad 2 over 2 because the cosine of 45 is adjacent over hypotenuse. Adjacent over hypotenuse. And we know that the tangent of 45 is rad 2 over 2 over rad 2 over 2 because the tangent of 45 is equal to the sine of 45 over the cosine of 45. We got the sine of 45 to be rad 2 over 2 up here. We got the cosine of 45 to be rad 2 over 2 up here. And that would reduce to 1. Or, also, I forgot to mention, or the tangent of 45 degrees is opposite over adjacent, right? So we have opposite over adjacent. And these all reduce to a tangent of 45 being 1, all right? And these are all things that you should have memorized. But this is written in degrees. All this stuff up here is written in degrees. And when we're thinking about circles, we need to think in radians, okay? So we're going to take all this information that we just figured out in degrees and we're going to translate it into radians, okay? So we're going to convert 45 degrees from degrees to radians. And I'm going to multiply it by a very smart version of 1. What do I mean by a smart version of 1? Well, we know that pi is 180 degrees. And 180 degrees is 180 degrees. So pi divided by 180 degrees would give me 1. I can multiply anything by iterations of 1. That's the idea behind rationalizing denominators, all sorts of stuff. So if I do the math across here, I would get pi over 4. Okay, so we have converted 45 degrees into pi over 4 radians. They are equivalent. So let's rewrite all the things that we figured out above. Sine of 45, cosine of 45, tangent of 45, but this time in radians. So we have the sine of pi over 4 equals rad 2 over 2. The cosine of pi over 4 equals rad 2 over 2. And the tangent of pi over 4 equals 1. These are all things that you should have memorized. These need to be at the ready. Okay.